All right. Hello, everyone. Good afternoon. At least it's afternoon for me here in Maryland. Hello, John. Hello, Kule. Hello, Collins. Hello, Osman. Hello, Manuel. Hello, Francis. Hello, Tulo Walona. Hello, John from Zambia. Hello, Danielle from Mexico. I've been to Mexico. This is very nice parts of Mexico I've been to. One of my good friends is from Mexico. Hello, Samuel from South Africa. I've not been to South Africa yet. Maybe someday. Hello, Vishal. Hello, Ain. Hello, Rafiet. Hello, Arian. Hello, Mansi from New Jersey. I don't know whether I should give you my commiserations or congratulations on being from New Jersey. There are some parts of Jersey which are nice, some parts which I think are not so nice. Hello, Helena, or Helena. Hello, Yanis from Greece. What do you guys want to talk about today? I guess there's probably some discussion on the IP mini project. Hello, Olalua from Nigeria. Hope I'm saying your name correct. Ayane. It's pronounced Ayane. Okay, I will try to remember that. Or Ayane. Ayane. I hope I'm saying that correct. Ayane from Uganda. Hello. Kule says, can we go through the IP mini project exercises? Yes, that was probably my plan for today. We had started yesterday. I could discuss a little on string interpolation. So string interpolation. Let me make a note here. Hello, Majid from Nigeria. Hello, Ibrahim from Nigeria. Yeah, I think we often have lots of students from Nigeria here in WorldQuant. I remember that from previous sessions. All right, any other things that you all want to discuss? Aristosthenes, the sieve of Aristosthenes or dynamic programming. We'll get to the sieve of Aristosthenes in the IP mini project. Revise iterations. Iterations in what contexts? For loops, list comprehensions. Mansi, for the end mini project, despite returning array 10, 20, 30, or even 10 getting the wrong answer, can you briefly touch on that? Mansi, you want to write a function that will work for any kind of list of numbers. Francis, for loops. All right. There's probably enough to talk about today here. Let me begin first by going to the in mini project here to discuss this. So the end mini project here, we have these two questions. Problem one was you needed to return the list of 5 even numbers. Problem two, right, you need to write a function you need to write a function. You don't want to return the list 10, 20, 30. You need to write a function which will work for any list of numbers. Right, so as I said, you want to write a function that will work for arbitrary input. All right, what's your function look like, Mancy, or anyone else? Return NP array. I don't want a NumPy array, I want a list. You return a list where each element is the element multiplied by 10. And I don't want to use test numbers, I want to use numbers. Remember, numbers is our variable name that we're using here. So I want to do a list comprehension. I want 10 times I, or I times 10 for I in numbers. Not test numbers, numbers. You don't want to print this list, you just want to return this list from this function. But we could try this out. Let me import the grader here as well so that things will work. So you don't want your function to print the list, you just want to return the list. So 3, 10, and 25, I get 30, 10, 30, 100, and 250. And multiply on, -1, minus 32 and 5, well, I get minus 10, minus 320, and 50. So again, I don't want my function to print out this list of numbers, I want it to return this list of numbers. And then if I submit this to the grader, well, the idea here is the grader has some test cases that it will use, and it will apply your mult function on those test cases and see if this function works correctly on those test cases. So no, you're not passing a list to the grader, you're passing basically the code, the name of the function itself. And as we said, this will run your function on some secret hidden test cases, and we'll check to see if the results your function is giving match, the correct answers. Match the expected answers. Right, and this is what you are going to do in some of the other mini project questions. You're going to write a function which will do some task, and you'll pass the name of the function to the grader, and the grader will run your function on some hidden test cases and check and make certain that your function is giving the correct output. So again, you don't want to print out the numbers here, you don't want to print the list, you just want to create and return the list from the function. And the grader is going to do its own checking. So hopefully, the idea, the goal here is clear, right? As I said, you want to write the function. For the IP mini project, we started this yesterday. Vishal asked the question, how does a grader really work? Well, so again, it's similar to, well, let's see here, right? We've written a function which will compute Mersenne numbers. We have our function which can check if a number is prime. For this question right here, in particular, it says, well, this is the format of the input that our grader is expecting in this case. Right? Alter the next cell to make use of the functions you defined to create the appropriate list of Mersenne numbers. We say here we want to make a list of the Mersenne numbers for all primes p between 3 and 65. There should be 17 of them. And this is, well, for example, why we see this 17 right here, right? This is a list of 17 numbers. So let me go back up here again and let's run the imports to get the grader. What do I need to do here? So exercise 1, right? We want to write a function, first of all, that accepts an exponent and returns the corresponding Mersenne number. Well, we did this yesterday. All right, remember the Mersenne numbers are the numbers 2 to the power p minus 1. Alka, I might ask you to wait on your questions on the VC mini project as we haven't actually gotten to the VC mini project yet. The idea in the schedule, well, this week's mini project is, IN and IP. And we're not yet to the VC mini project. So if you could hold your questions. So our function right here, this was one of our Mersenne numbers, right, 4 cubed minus 1. We want to define a function that, given a number p, will compute the Mersenne number. No, Giannis, to answer your question, no, we don't necessarily have to assume that p is a prime number. It's just a Mersenne number is any number that can be written as 2 to the power p minus 1 for some p. Ibrahim, I'm not entirely certain what the problem may be if you're not seeing me. I'm assuming some other people can see me, I hope, fingers crossed. Hopefully the resolution is good. I can make things a bit larger here. Of course, it gives me a bit less room to work with, but maybe this will help the resolution. My only suggestion, might be, well, Ibrahim, you might try reloading reloading your feed. Yeah, Mersenne numbers are not necessarily prime. Even if p is a prime, that Mersenne number need not be a prime number. Someone asked this question earlier, 2 raised to the 11 power minus 1. This is a Mersenne number. 11 is a prime number, but 2047 is not a prime number. 2047, if I remember correctly, is divisible by 89. So 23 times 89 is 2047. 2047 is a Mersenne number, but is not a prime number, even though 11 is a prime number. So not every Mersenne number is prime, even if the exponent p is a prime number. Anyway, so we have a function which will compute the Mersenne number for a given exponent p. And, we can do a few tests, right? When p is 5, when p is 10, when p is 100. These are the corresponding Mersenne numbers. Right. Mersenne numbers can only be prime if their exponent p is a prime. But remember, that's only one way. If p is a prime number, the Mersenne number might or may not be a prime number. But they can only be prime numbers if the exponent is prime. So we want to make a list of Mersenne numbers for all the primes p between 3 and 65, of which we're told there should be 17 prime numbers between 3 and 65. Said, well, it may be useful to modify the isPrime and getPrime functions from the program flow notebook. Manuel, the office hours will be transferred into the shared folder. If you go to video downloads, they will be put in the shared folder, but in office hours videos, but this will likely be done about once a week, towards the end of the week, because I have many things I need to do during the week. So again, we want to have a way of finding, prime numbers. Right? Well, I basically went to the program flow notebook and copied the isPrime function. And this is the isPrime function that was present in the program flow notebook. And right, so we could, I'm using this isPrime function. Apologies here, let me go back to this. Right, isPrime, so I'm using this isPrime function. We'll check, is 21 a prime? No. Is 13 a prime? Yes. Is 193 a prime? Yes. Is 2 a prime? Yes. Is 3 a prime? Yes. Okay. Is 1 a prime number? No. That's good. We want to write a getPrimes function. I'm going to change this. Yesterday I wrote a docstring that says between and including nstart. I'm going to change this slightly to kind of match how we might consider the for loop. Alka, no, you can't give a for loop in that fashion. That's a kind of C or Java style for loop. You can't give a for loop in that fashion in Python. I'm going to modify my docstring a bit, and I'm going to return the prime numbers between nstart, where I include nstart, and then end, but I don't include an end. in the similar kind of fashion as the range function will work. So I want all the prime numbers. I'm going to delete some of these cells here. So I want to use my isPrime function, and I want to return all the numbers. Emmanuel, I think you are thinking of things like the timeit, which is the so-called Jupyter magic. Just ways of doing certain things in Jupyter notebooks here. I want to check all of the numbers in this range and return only the prime numbers. Now, right, remember I could use a list comprehension, so for I in range 10 to 20. I in range. Right, this will give me a list comprehension. If I only want to keep the even numbers, I could add on a if condition. If I mod 2 is equal to 0. This will give me all the even numbers. So yeah, we could use a for loop. I mean, we could try a few different things here. So let's say result is an empty list for I in range n start and end colon. I want to do something. If is prime I, we have the is prime I function. I could append I to this list, and then I could return my result. So get primes 2 and 20. This will give me the primes 2, 3, 5, 7, 11, 13, 17, 19. I think we were asked for 3 and 65. And this gives me this list of prime numbers. What is the length of this list? I could say what is the length of get primes is 17. That's promising. Now I could build my list in this fashion. It would be considered more Pythonic to build this list using a list comprehension. Right, list comprehensions are common in Python code. You should become familiar with reading and writing your own list comprehensions. List comprehensions are generally faster than writing a corresponding for loop to generate the list. This is partly because, well, the Python developers have spent a lot of time to interpret Python list comprehensions and run them very quickly. Lily, in answer to your question, no, you do not need to do all the exercises in order to pass the course. The only thing that we care about in terms of the problems that you solve are the mini project questions. All questions on all mini projects. Right, as we said here, the graduation requirements, you have to pass the course and get your badge, you must achieve a score greater than 0 for every question in every mini project. If you want a Credly badge with honors, you have to achieve an average score of 0.9 or greater across every question in every mini project. So we are only looking at the mini project questions. This is what you will see here on your grades. Right, these are all the questions on the mini projects. Ulrich asks, is a Mersenne number, is it necessarily prime? No. So I've written the getPrimes function in this fashion using I start out with an empty list and I append elements that I want to keep. I could rewrite my getPrimes function to use a list comprehension to compute this result. I could say I want to build a list, I want to return I for I in range and start, and start and end. This will give me all of the numbers in this range. I don't want all the numbers in this range. I only want the numbers in this range which are prime numbers. So I will only keep those numbers in this range if those numbers, if that number is a prime number. I only keep the values I if that value is prime. And well, I've just redefined my getPrimes function to return this, to do this computation in a list comprehension. But well, they give me the exact same results as before. getPrimes from 1 to 100. These are all the prime numbers between 1 and 100. So I said, well, right, either code cell here is correct in that it gives you, the correct answer. Right? This version of getPrimes and this version of getPrimes will give you the exact same result. It's more common to see the code written in this fashion using the list comprehension. I said Python programmers are often using list comprehensions. And if you want to read other people's code, well, you should become familiar with list comprehension so that you could understand what they are doing, and so that you could write your own list comprehensions. Right? The amount of code I've written in this cell is, smaller than the amount of code I've written in this cell here. And this list comprehension version right here is, to use the phrase, it's the more Pythonic version, in that if you are, if a experienced Python programmer was writing this code, he or she is going to be more likely to write this code here. And this code is actually going to be faster in general than this code here. Dennis, yes, the videos are recorded. You access the videos by, for example, going to the video links, scrolling down to the bottom here, the video links, and there's a playlist of office hours, which will have all of the office hours on this playlist. Samuel, you can add more cells in your Jupyter Notebook. Right? You could edit, let's see here. The plus symbol right here is a way to add a cell below your current cell. Or if you want to use the keyboard, if you select, a cell and I hit the letter A, this will add a cell above my current cell. Or if I select the cell and I hit the letter B, this will add a cell below my current cell. That's if you're in the kind of command mode, so to speak. This won't work if I am inside a cell, if I'm typing things here, because, well, the A or B will just give me letters A or B. So yes, feel free to add more cells in your Jupyter Notebook for testing things out. Is there any question about this getPrimes function? I want to spend a bit of time, say, talking about some of these other things today as well. Right, but we could... it could be possible to solve a problem in one cell. Yes, that could certainly be the case too. I mean, I could write lots of code in one cell. What did we have? So we have a getPrimes function here. We're told, let's remind ourselves, I want all the prime numbers between 3 and 65. Must we use the numbers given in the many projects, or can we write our own numbers? I'm not certain exactly what you mean. Well, but I mean, here we're specifically told, make a list of the Mersenne numbers for all primes between 3 and 65. That is the goal of this particular question. If I make a list, of other numbers and submit it to the grader, I'm not going to get a score of 1. If I make a list of the wrong size, the wrong length, I'm not going to get a grade. The grader will complain and say, oh, hey, it'll give me a message that will basically tell me your list is too short or too long. So yes, for this question, we must make a list of numbers for all primes between 3 and 65. If I don't make that list, then I'm not going to get the grade of 1. Right? But we're kind of, working towards that kind of solution, right? I need all the prime numbers between 3 and 65. Well, we have a function to check if a number is prime. We have a function here now to get prime numbers between two numbers. So, right, for example, I say, the primes I want are get primes 3 and 65. Sabine, the link of office hours in Unit 2 is the same link you use to get here. You just want different times for Unit 2. I don't remember what those times are. They should be in the email that you received for Unit 2. Right, so the primes I want, if I get the case correct, these are the prime numbers that we want. Sabine, this is Unit 1 that you are in. If you're looking for Unit 1, you're in the right place. If you're looking for Unit 2, you need to come back at a different time. So I have the primes here the prime numbers I want. Now I just have to compute the corresponding Mersenne numbers that I want. Unfortunately, I have no way of making my mouse cursor visible. Unfortunately, that I know of. I will have to see if there's a way that I could do that. I've tried doing this before and I've never found a way of making my mouse cursor visible on this YouTube stream. This is why I'm often highlighting text, because I don't know a way of making my mouse cursor visible. Now, I have the list of prime numbers that I want. Now I need to make the corresponding list of Mersenne numbers. Well, I have the function that will compute Mersenne numbers for me, right, given an exponent. I could say Mersenne of I for I in the primes I want list. What's my function called? Mersenne number. Right, these are the Mersenne numbers I want. Now, I can just save these. I say Mersennes equals this list. I'm not going to evaluate this cell because this is going to assign my list to be something that I don't want. But my Mersennes, if I could spell, this is my list of Mersenne numbers that I want, right? 2 cubed minus 1, 2 to the 5th power minus 1, 2 to the 7th power minus 1. 2 to the 11th power minus 1, etc., etc. And I could submit this to the grader, right? My Mersane's list that I've created here, I can submit this to the grader, and I've gotten things correct. Right? If I submitted something that's incorrect or only partially correct, like this list here, well, I get a worse grade. If I submit something which has the wrong size, the wrong number of elements in it, like instead of a list of 17 numbers, I'm told my solution did not match the expected type, 17 times numbers. Right? This is telling me, well, you know, my solution needs to have it's a list of 17 numbers in it. But my list that I submitted only had 16 numbers in it. So if my list is too short or too long, I will basically receive a message of this form. Iman, you should be able to find this on your own Jupyter pod by going to my server, click on Data Course and Python and Mini Projects and its IP. Can the enter button submit? No. You have to run the code cell like you would run any other code cell in, a Jupyter Notebook to perform the submission. So I have to execute, this is Python code. I have to execute this Python code to perform the submission. If I go back and I evaluate this to define my variable and I evaluate this code cell, well, I'm back to my score of 1. Jide, to answer your question, the largest known prime numbers as of this day, they are all Mersenne prime numbers. They're all Mersenne numbers. Which, well, if you went to the Wikipedia page on Mersenne primes, you could find this out. Yeah, the largest known prime number as of this date is a Mersenne number. There's a request to see the isPrime function. This isPrime function is exactly the same isPrime function that we got from the Program Flow notebook. I opened up the Program Flow notebook and literally copied and pasted this isPrime function right here. We could write an improved isPrime function, one that will run faster, which was suggested later on in this particular mini project notebook. We're told, oh, here's some suggestions of how you might write, and you might modify this isPrime function so that it will run faster. Like, for example, right, the only even prime number is 2. So I could check, is my number equal to 2? If it is, return true. Otherwise, if it's an even number, return false. And then I wouldn't have to check all factors because I could skip over the even factors. aside from 2. Right, so I could say well, yeah, Mersenne is taking, this variable here, which is a list. So yeah, you could change this variable to something else and submit that variable to the grader here. All right, this is what I did here. I changed the variable to this list. And, well, I submit. What is the real-world significance of Mersenne numbers? Well, large prime numbers, I think this was mentioned earlier in this mini project. Large prime numbers are useful for encryption. The internet, as we know it, is basically, in terms of shopping, right? If I send my credit card number on a shopping website, I would hope that my credit card number is secure. And what's going on behind the scenes is that, well, my browser and the server are exchanging some information to encrypt my credit card number. And yeah, large prime numbers are useful for the purposes of encryption. Is there any question on anything that I have done here today? You know, I can upload my version of this notebook to your shared folder. I might clean things up a little bit before I do. But, you know, right, we're kind of slowly working through, right? We wanted to define this Mersenne number function. I'm checking it, I'm verifying that it works. We wanted our isPrime function again. Well, I'm checking to see that my isPrime function works, but as you said, well, I copied and pasted this from the program flow notebook. I would write a getPrimes function. You know, as I said, either version works, right? But I want to write a getPrimes function, and well, I want to check to see that this function works. And then, you know, right, we wanted to get these 17 prime numbers between 3 and 65. And, you know, then I want to compute Mersenne numbers. I mean, Hannibal will kind of work through the mini projects, but, you know, I'm expecting that you guys will, like, make suggestions. We'll work on these mini projects yourself. I probably won't give you solutions to every mini project question because, well, you guys should be doing some of this work yourself. Now, I only have about 10 minutes or so left. Let me talk. Someone asked about string interpolation. Sorry, I should have written down your name. Yeah, we're several things. I mean, what did you want to talk about hashing? I mean, some things I didn't get to today, we could get to tomorrow and in future office hours. Let me come back here. Let's make a new notebook. What in particular, I forget who asked the question. It might be you, Ayine, if I'm remembering your name, the pronunciation correctly. Like Python has a hash function available. If I hash a number, I get that number back. Oops, if I hash that number, I get that number back. right? Hashing is used in the creation of dictionaries. So, all right, so we'll add here, I could add default dict. And memoization. There's a question, did I use this with this cell here? Well, as was pointed out, that was the dummy solution. This was the dummy solution. This is telling me, this is a reminder that this is the format of the solution that I want. I want a list of 17 numbers. So I didn't really use this except to remind myself that the format of the solution that I want is 17 numbers, a list of 17 numbers. Right, like in exercise 2, we're told, well, I want my result should be a list of 16 numbers that I'm submitting to the grader here. We can talk about mapping, the map method in Python. Well, I can add this to the list of things to talk about. And Lambda functions, lots of things. Too much for 1 office hour or even 2 office hours. Lambda functions. So who was it that asked about hashing? Right, hashing is used for dictionaries, but it's used kind of internally by the interpreter. It's usually not something that I use or think about a lot myself. Right, when if I define a dictionary, let's make something that I could possibly remember how to type. Right, if I make a dictionary, of course my dictionary can have both strings and number and integers, say, as keys. What Python is doing behind the scenes is it's hashing my keys to get a memory location. But I often don't have to, remember, I don't have to worry about this. This is done for me. Hashing, we can talk about hash functions. What is the hash function doing? Return the hash value for a given object. 2 objects that compare equal must always have the same hash value, but the reverse is not necessarily true. What Python is doing internally is it's computing the hash value of the key, and this is giving some value, and this is essentially used, or some version of this is used as a memory location. But again, for dictionaries, I don't have to explicitly worry about how the hashing is done. It's done internally for me. So some other string, will likely hash to a different value. It's possible, I have no idea, I don't know an example of 2 strings that will hash, 2 different strings that will hash to the same value. It is possible, but I don't know of an example in Python. But that's how hashing, that's one way hashing is used in Python. It's used internally by the interpreter. and looking up keys in dictionaries. Has hashing any relation with encryption methods? Well, some people might use the word hashing when they are talking about encryption, but to me, no. It doesn't really have any relation with encryption methods. So I'm not sure I have a whole lot more to say about hashing. As I said, it's, this kind of hash function is used internally mostly by Python. I typically don't run across situations where I need to use this hash function myself. Except possibly if I define a class, a custom class, I can define a method, a hashing method for that class, which will then be used by Python, internally for instances of that class. But beyond that, I don't often find myself needing to use this hashing kind of function. So as I said, I don't really have much more to say about this. I have 4 minutes remaining. What could I fit in 4 minutes? Well, I might talk a little bit about a default dict. The default dict lives in the collections module. What is a default dict? Well, it's a dictionary. It's essentially a dictionary, but I could define a default value, right? I have this dictionary D defined above. If I give it a key which doesn't exist in the dictionary and I use square brackets, this is a key error. Right? This is a key that does not exist in my dictionary. My dictionary only has 2 keys in it. There is, I should point out, a dictionary has a get method. If I supply a key to the get method which exists in the dictionary, this will find the corresponding value in the dictionary. If I supply a key that doesn't exist in the dictionary to the get method, it's not an error. I get something back from this function, but it's not obvious that I get something back in this case unless I print it. The get method, if I supply a key to the dictionary that doesn't exist, it returns none by default, right? The special Python value none. The get method is useful though because I could supply a default value. Right? If I say d.get k, I could supply a default value. If that key doesn't exist in the dictionary, I get back that default value. Whereas if I supply a key that does exist in the dictionary, I will get the corresponding value back associated with that key. So the get method in the dictionary, right, get will return, you give a key, returns the value for the key if the key is in the dictionary, else it returns the default value. Or the default is none. But I could always supply, a new value. If I make a default dictionary, default dict, I could supply a function And what would happen is that if I ask for a key that doesn't exist in this default dictionary, this function right here is used. And the int function with no argument returns 0. I could create another default dictionary and supply a function like lambda and the number 32. If I ask for a non-existent key in this default dictionary, I get back this value right here that I have defined. So a default dictionary, is another way of defining a default value, and the value does not necessarily need to be a number. Ibrahim, if you check the questions board, I believe there's already a WhatsApp group or a Discord group or some sort of group that has been formed by other students. So check the question board and, look for WhatsApp, or I think there may be a Discord group. I don't know. The students have organized something already. So I could say a little bit more about default dictionaries tomorrow, and we could get to some of these other things tomorrow as well. So yeah, as I said, check the message board, I think, for information about the WhatsApp group or whatever groups have been formed by the students. So I'm going to end things there for today, and I will see you all tomorrow. Tomorrow's Thursday. Yes, I'll see you tomorrow. So thank you very much for the questions, and as we said, yeah, we can get to some more of these things tomorrow. Ibrahim, I don't know how you could join the group. As I said, you'll have to check the Q&A board and for information about how you can join, or ask other students. I don't know. I'm not running the WhatsApp group. So yes, we'll see you all tomorrow. So thanks for the questions, thanks for the feedback, and